Okay, this is question 2 from the P3 paper, January 2022. Let's have a look at it. We can see that it's a trigonometry question. It's actually going to be the double angle formulae. I can see that from the fact that I've got sine 2 theta in there. Let's not get ahead of ourselves. Let's actually just get started with the question. Part A. What does it say? It says, show that the equation 8 cos theta equals 3 cosec theta can be written in this form here. So, not too worried about the actual sine 2 theta equals k bit. Let's just get started. I've got that 8 cos theta is going to be equal to 3 cosec theta. And from our work with trigonometry, we know that cosec is the same as 1 over sine. So I'm going to change that to 8 cos theta equals 3 over sine theta. Now I can see exactly what to do from here, because what I've done is to go away and make sure I've learnt the trigonometric identities inside out. I'll tell you my thought process, which is what I'd probably like to do is to get rid of the sine theta as a fraction. If I do that, I'm going to end up with sine theta cos theta. And I know that sine 2a is 2 sine a cos a. So I'm well on the way to my answer there. If you didn't have that much knowledge of that one, then they are at least giving you a bit of a clue at the top there by saying we need to get sine 2 theta. And so that should, as a hint, remind you, sine 2 theta is 2 sine theta cos theta. But anyway, let's actually go and do this thing. So the next thing I'm going to do is multiply both sides by sine theta. And purely because of the way that I know it's set up on identities and things, I'm actually going to write that left-hand side as 8 sine theta cos theta. Doesn't matter the order of them, but to try and help me with all my memories and my going through and doing the identities and everything, I've got that stage. And so that's why, with my next step, people might be saying, well, how did you know to do that? I've already told you. I already knew, and I'm always looking for 2 sine theta cos theta somewhere, because I know that's a trig identity. So actually then just making that step of factorising is the logical next step to do. Well, if I've got that, then I can now replace this. With 4 sine 2 theta equals 3. And then obviously the logical step after that will be to say sine 2 theta equals 3/4. And actually, if we now go back to the question, that's what we were trying to do. We were trying to get sine 2 theta equals k. In this case, I pretty much got to the answer before I worried about checking back to see what I was trying to prove there. So, part A done. K is equal to 3/4. Part B says, find the smallest positive solution of that equation, and the solution of that equation is going to be the same as the solution of that equation because of all the work that we've just done here. So actually, for part B here now, when I'm trying to solve 8 cos theta equals 3 cosec theta, we can straight away say that's the same as sine 2 theta equals 3/4. Yes, they like using part A to solve part B here, so we're just solving this. Okay, that's really, really straightforward. If sine is equal to 3/4, then 2 theta is equal to sine to the -1. A quick check, I've already done it, but a quick check, is it radians? Is it significant figures? No, the question was answer in degrees and correct to 1 decimal place there. So if we now do that, stick it into the calculator, 2 theta works out to be equal to 48.6 degrees, which means theta works out to be equal to 24.3 degrees. So I've read the question already properly. We want the smallest positive solution, which is the first value that will get the first acute angle, and that's straight away there. They could have tried to make that a little bit more difficult, using some of our work to do with our cast diagram and whatever, but no, straightforward with that one. That's how you do question 2.